Hello and welcome to my explanation of question 4 for MATH142 assignment 1. The question asks us to find a limit as x approaches 0 of this function right here. First of all, we want to separate the 2 from the equation as it is constant. By doing so, we can find that as x approaches 0, 2 remains 2 since it's constant. Now I want to focus on this function right here. First of all, making the denominators equal by multiplying sine x on the top and bottom of this function right here and x on the top and bottom of this function right here. This then gives us a limit of x approaches 0 of sine x minus x all over x sine x plus 2. Now we apply the limit as x approaches 0 by letting x equal 0. We then get this function right here. Knowing that sine 0 equals 0, we then find that it equals 0 on 0 plus 2. Since it is 0 on 0, we can apply L'Hopital's rule, which then just means applying the differential on top and bottom of the equation. So if we apply the chain rule of x sine x, we find that it equals sine x plus x cos x. In the top, it simply is differential of sine x minus x, which becomes cos x minus 1. We then apply the limit again of x approaches 0. This then becomes cos 0 minus 1 all over sine 0 plus 0 cos 0 plus 2, which then becomes 0 on 0 as cos 0 becomes 1 and 1 minus 1 equals 0. Since it's 0 on 0, we can then apply L'Hopital's rule again. Once again, applying chain rule to the x cos x on the denominator, giving us negative sine x on the numerator because we differentiated cos x minus 1 and that became negative sine x, as differential of cos x is negative sine x, all over cos x minus x sine x plus cos x. That part there, the chain rule for that part there, and we just had to differentiate sine x there. Okay, and now we can simplify cos x plus cos x to cos x. We then can apply it as x approaches 0 again by letting x equal 0. We then get negative sine 0 all over 2 cos 0 minus 0 sine 0. Since cos 0 equals 1, we then get 0 on 2 plus 2. But since it's 0 on 2 and not 0 on 0, we cannot apply L'Hopital's rule. Therefore, the limit equals 0 plus 2. So the solution for this limit of 1 over x minus 1 over sine x plus 2 as it approaches 0 would be 2.